Hi everyone. So today we'll see prime numbers and composite numbers. So what is a prime number? Any natural number that has exactly two distinct factors. So important natural number, so integers for sure. Exactly two different factors which are one and itself. Okay. So first of all, natural numbers, that means no negatives can be prime. It should have two distinct factors. For example, the first prime number is 2. What are the factors of 2? 1 and 2 itself. Because there is no other way we can write 2, right? Similarly, 3 is 1 into 3. So any number which you can only write as 1 into itself. So that means the factors are 1 and the number itself. So the prime numbers are 2, 3, 5, 7 and so on, with 2 being the only even prime number. Only even prime number. And now some of you can have this doubt why 1 cannot be a prime, right? Because I see a lot of students getting confused. 1, why is it not prime? Because 1, you can write 1 and 1 into 1, but the definition of prime number is it should have two different factors, right? So the problem with 1 is there are no different factors. So that's why 1 cannot be considered as the prime number. Now, obviously, composite is something, any natural number which has more than two factors. Prime number, exactly two different. Composite, more than two distinct factors. Right? So as you can see, 4. What are the factors we can think of? 1, 2, and the number itself. Next, 6. 1, 2, 3, and the number itself. So any number, any natural number which is neither 1 nor prime is a composite, right? So this is also important. 1 is neither prime nor composite, and 2 is the only even prime number. So make sure you write all the definitions and even the questions. So we'll solve 2-3 questions. State true or false for each of the following. First one, all primes are odd. Absolutely not, right? So this is false. Product of any two primes can be prime. Okay, is it possible? Take anything. So let's say we'll take one even and one odd. This is not prime, this is composite, right? So the definition of prime number, we have seen that the number has to be, can only be written like this, right? Here 6 we can write as 2 into 3 or 1 into 6, or there are more than two distinct factors, right? Now the same way, let's take two odd, 3 and 5, which is 15. Is 15 prime? The answer is no, because the factors are 1, 3, 5, 15, more than two distinct factors. Can be a prime? No, it is false. Sum of two primes is always even. So the wording always, let us see. We have a even prime number 2 plus 3. So this doesn't satisfy, this is odd. Now if I add two odd prime numbers, so this is, yes, even. But is it always even? The answer is no. So this is also false. Okay, so just be careful about the wordings used in the exam. Okay, P is a prime number greater than 5. Okay, what is a remainder when P square is divided by 8? So these are the prime numbers and so on. So since we are looking at prime number greater than 5, we'll let go of these 3. So I would like to just substitute 1 or 2 values and get the remainder. For example, if I take p as 7, p square is 49. So what is the remainder when you divide 49 by 8? So we know, most of you would be knowing the 8 table. 8 6s are 48. So the remainder is 1. Okay, just to confirm, we'll check for one more value. So let's say if I take prime number as 11, p square is 11 square, which is 121. Now if I check, when I divide 121 by 8, so 8 ones are 8, I have 4 and 1 comes here, so 8 5s are 40, right? Again, remainder is 1. So this is good enough to check that the remainder is always 1. You can make a note, this is a bit on the higher level. Basically, any prime greater than 5 is always of the form 6n plus or minus 1. Now what does that mean? Any prime number greater than 5 is a multiple of 6. Plus or minus 1. For example, you take 7, right? 7 is 6 plus 1. The next 11 is 12 minus 1. 13. 12 plus 1, right? You take anything, 23 you take. 6 into 4, 24 minus 1. You take 29, which is a prime. Yeah, 6 into 5 minus 1. 31 is 6 into 5 plus 1. So any prime number greater than 5 or greater than 3, see, even 5 is what? 6 minus 1. So any prime greater than 3, my bad, is always of the form 6 plus or 6n plus or minus 1, which is multiple of 6, right? Now, we'll see one last question. Okay, if x is greater than 3 and less than 100, so what do you understand from this? Greater than 3 can be 4, 5, 6 and up to 99. Now x can take decimals. If I just look at this statement, like x can be 3.1 also. But if we go ahead, for how many values of x is x by 3 the square of a prime number? X by 3 is the square of some prime number. So from here we know that x is 3 multiplied, 3 goes to the other side, by prime number, right? Now prime numbers are integers and 3 multiplied by an integer is always an integer. So x can take this up to 99, from 4 to 99. So what we'll do is we'll just list down the prime numbers. So the question is not asking for the values, rather asking how many values of x are there. Okay. There's no need to go beyond 7, because if prime number is 11, 11 square is already greater than 100, right? So 3 multiplied by that is anyways greater. So we can just check up to 7. So prime number squares. So 2 square, 3 square, 5 square, 7 square. Now x is what? 3 multiplied by the, so which is 3 multiplied by 4, 3 multiplied by 9. You multiply all these squares. and check how many of these values are falling in this range, right? So this falls. 3 into 4, 3 into 9 definitely falls. 3 into 25, 75, right? This definitely falls. 3 multiplied by 49, this does not. This is greater than 100. So how many values? 3 values of x are possible. Okay. So I hope this is clear. So make sure you write all the notes and the questions. I'll see you in the next video. Thank you.